let's look at a projectile motion problem. So the problem says that a ball is kicked with an initial velocity of 25 meters per second at an angle of 30 degrees above the horizontal from a 2-meter high wall. We're to determine the time the ball is in the air, the time for the ball to reach the top of its trajectory, the horizontal distance it travels, the maximum height of the ball measured from the ground, and the final velocity of the ball when it strikes the ground. So let's get into the habit of writing down our knowns, our known quantities, and then our unknowns and the equations that we're supposed to be using. So the things that we know is that the ball is kicked with an initial velocity of 25 meters per second. So V initial is 25 meters per second. And the angle that it makes with the horizontal is 30 degrees. So let's call this angle theta, and it's 30 degrees. We also know that it's being kicked from a height of 2 meters. So call this height y naught 2 meters. Now, other things that we know, since it's a projectile motion problem, are that the acceleration in the x direction is 0. We also know that the acceleration in the y direction is the gravitational acceleration, so that is negative 9.8 meters per second squared. So these are things that are not listed in the problem, but there are things that we know about projectile motion. We also know that since the acceleration in the x direction is 0, the x component of the velocity is constant, and it's equal to the initial x component of the velocity. What else do we know? So when the ball reaches its maximum height, that's when it starts coming back towards the ground, meaning that for a split second, the velocity in the y direction is 0. So velocity y at the top of the trajectory is 0. So these last things are things that are specific for projectile motion problems. So I wrote them here so that I wouldn't forget them. All right, now what we're looking for, so the unknown that we will need to solve for, are the time the ball is in the air, the time for the ball to reach the top, so we want t to the top, so I'll call that t top. We're looking for the horizontal distance it travels, so that's going to be an x, a delta x really. But if I measure the original position of the ball, if I call that x equals 0, then all I need is x. I don't need to write delta x down. All right, for part D, we want the maximum height of the ball measured from the ground, so we want y top. And E, we want the final velocity of the ball when it strikes the ground, so that's v final, and we're looking for a velocity. So these things are what we will set out to find. Now, since we're dealing with projectile motion, there are a few equations that we know we can use. So in the x direction, the only equation we can use is x is v0x times t, because all of the other kinematic equations include the acceleration, and the acceleration in the x direction is 0. In the y direction, we have all three of the kinematic equations, so we have vy equals v initial y plus a y t. Then we have y equals y naught plus v naught y t plus 1/2 a y t squared. And the third equation is v y squared equals v naught y squared plus 2a delta y. All right, so how about we draw a diagram of the situation of the problem. So here we have a 2-meter high wall. There's the ground level, and here's the ball, and the ball is being kicked with an initial velocity v naught at an angle of 30 degrees above the horizontal. So what this ball will do is it will follow a projectile motion path. Let's see if I can draw that a little bit nicer. Something like that. And then it strikes the ground with a certain velocity v final. All right, so we know that this height is 2 meters, and that's about all we know about the problem. So first question is to find the time that the ball will be in the air. Now, if we look at this equation, we do have time in the equation. We have v0x, which we can calculate, but we don't know the horizontal distance, so we cannot use this equation. In this equation, in the y direction, we do not know vy final. We know the initial velocity in the y direction. We know the acceleration, but we don't know the time. So we have two unknowns in this equation. We can't use it. In this equation, we know the final height. That's when the ball hits the ground, so that's 0. We know the initial height. It's 2 meters off the ground. We know the initial velocity in the y direction. We're looking for time. We know the acceleration, and we're looking for time. So it looks like we have a winner. We can use that equation to find the time. So for part A, we rewrite the equation y equals y naught plus v0yt plus 1/2 at squared. I can plug in the numbers. So y is the final position of the ball. That would be, whoops, right here. That's the final position of the ball. Y initial is 2 meters above the ground. So y final is 0. Y initial is 2 meters. v0y. So we want the y component of the velocity. So that will be v naught sine 30. So that's 25 meters per second times sine 30 times time plus 1/2 times the acceleration, which is negative 9.8 meters per second squared times time squared. So in this equation, I know everything except for time. I plugged it into my calculator, and I get two values for the time since it's a quadratic equation. So I get negative 0.15 seconds and 2.7 seconds. Now, time only goes forward, so I'm going to pick the positive value for the time. So I found the time that the ball is in the air. In part B, I am looking for the time it takes for the ball to go to the top of the trajectory. So I want the time it takes to go from here to the very top. Now, what I said there is that the velocity at the top is 0. So I can use, let's see, which equation can I use? How about this one? Because I know that Vy is 0. V0y is V naught sine 30. The acceleration is negative 9.8, so I can solve for the time. So Vy equals V0y plus AYT, And I'm going to make a note here that Vy is the velocity at the top. So that is 0. And then this is equal to V0y, which is 25 meters per second times sine 30 plus negative 9.8 meters per second squared times time. I solve for the time and get 1.28 seconds. So this is the time it takes to go to the top of the trajectory. So let's compare the two time values that we have obtained so far. So I have a 1.28 seconds for the ball to go from the wall to the highest point, and I have 2.7 seconds that it takes for the ball to go from the top all the way to the bottom of the to the ground level. Do these values make sense? So if I double the time it takes to go to the top, I get less than 2.7 seconds. So that makes sense because it should take more than twice. So let me draw a horizontal line here. It should take more than twice for the ball to get to the top and back to this level. That's what twice speed of time to the top will be. So it should take more than that to get all the way to the bottom. So I believe that our calculations are correct. All right, in part C, what are we looking for? The total, the range of this motion. So now we're moving into the x direction equation. There's only one of them. So x is v0x times time. This time is the time that the ball is in the air, that it goes from here all the way to the ground. So we know everything except for x. So x is going to be v0x. Let me write that a little bit neater. So it's v0x times time, and that is 25 meters per second times cosine 30 times time, which is 2.7 seconds. So when we plug the numbers in, we get 58.5 meters. All right. In part D, we're looking for the maximum height of the ball. So we want to know the height at this point. So we can use let's use this equation, because we know that the maximum, the speed of the ball in the y direction at the top is 0. We know what it is when it first starts, is v0 sine 30. We know the acceleration of gravity. We can solve for the delta y. So Vy squared, this is Vy top, equals V naught y squared plus 2a delta y. So 0 equals 25 meters per second times sine 30 quantity squared plus 2 times negative 9.8 meters per second squared times delta y. So that's y final minus y initial. Y final is y top, y initial is 2 meters. When we solve for this, we get y top is 9.97 meters. Okay? Then the last part, we're looking for the velocity when the ball strikes the ground. So one thing we know is that the velocity in the x direction is constant throughout the motion. So that is v naught cosine 30, or 21.65 meters per second. Then to find the velocity in the y direction, we can use Vy equals v0y plus at. So v0y is 25 meters per second sine 30 plus negative 9.8 meters per second squared times the time, that is 2.7 seconds. And that will give us negative 13.96 meters per second. Now, the fact that it's negative means that it's pointing down, which is correct. So v final then is square root vx squared plus vy squared. Plugging in the numbers, we get 25.76 meters per second. And then we're looking for velocity, so the angle, call it phi, is inverse tangent of 13.96 of the y component divided by the x component, and that will be 32.8 degrees with respect to the horizontal, so it's below the plus x axis. And this is the end of the problem.